Hey guys, so welcome back. Well, we're working on this 1930 Philco Model 20, and we've done a lot of work on it. We've gotten some things, items inside that were broken, fixed. We fixed a coil that had a blown wire in the coil. We got that taken care of. We've got a number of the other electrical issues taken care of this. We got it where it would play and play well, by the way. We had a couple of things that still need to be resolved. I'll pop them up here on the side. You can see them, and they've now been turned green. But we had a problem with the power transformer. The wiring on it was all bare, and it was missing half the clamshell. We got that repaired. We had a power switch that did not work. We bypassed it for getting the test to work, but we then went in part 4 and took this apart and restored it. And now this 94-year-old switch works. And we kind of had those as two separate episodes. I hope you kind of enjoyed seeing some focus on restoration of these things that are almost 100 years old, and looking at some of the technology was kind of interesting in those days. Okay, but you know, as you can see, I screwed up by painting the power transformer, so now I gotta do more. So I'm going to get this thing cleaned up. But then I'm going to get into working on the electrical restoration on this, finishing it up. I got to do some work with the power cord and so forth. Power cord, I want to put a fuse on it to protect this transformer now that we've got it done. We get all that done, and we'll see if we can get this thing ready to come off the bench to where this thing would be ready to go. So we're going to get started on that in this episode. It's weather's is nice right now. I want to take this thing out and clean it up. I'm not going to bore you with that. But then we'll get back into the electrical restoration of this thing and get the wiring of the transformer and everything back in. So hang on, we're going to get started. In an earlier episode, I talked about the way this was acting up. It has a, get this kind of, it's got a spring-loaded deal here that squeezes these two plates together. Brass, I guess, and what it does is they squeeze on this piece here, and that's what drives this back and forth. It's a little rough. I'm not even sure that's straight anymore, but you can get that off. Now the way you get this installed is you got to take these two rings and bring them up to where there's this relief here, and it'll pop out. So it comes to there, and now that will slip out of there. And there you go. You can get those two separated. I may see if there's something I can do with this, but it's got a little split right here. We'll see what we can do with this. It's got to have something done with it because it's interfering inside the mechanism. It's jamming, and you can see where it even broke off a corner. So we'll set that aside, and we'll see what we can do with that later. This I'm going to work on some of these components, make sure it's got no burrs and things hanging up. So we'll get that taken care of as well. So here's that filter capacitor that we no longer need. I'm going to leave it on there just for looks, but I'm not going to restuff it or any of that stuff. I'm just going to use it for looks. Okay, so this clip is folded down on this side, and this is the end that's caught here. I'm just going to use this to keep this from going into another orbit if it wants to. Okay, that's that one. So that's the front one. I'm going to hold it on this side. It says a longer length, so it's a longer beam to deflect, so it'll be easier to move, I think. There we go. That went underneath, and that's like this. This should just lift up in the front and want to be fed through. Let's see, let's get this not engaged. That. Now you can lift this front end up and it should slip out. The main thing you want to do is not bend those vanes. Okay, here we go. First time out in 94 years, I would presume. Not too bad, we'll get this all cleaned up. Okay, the lower part here, it's got some contacts on this end that are attached, 3 of them, and I don't know if I can reach them from inside here. I'm going to try. Let's see, is this the way to do it? Let's see. These veins will come out when I disconnect that. If I remove this frame, I'll be able to maneuver it away from these cans and make it easier to work on, I think. Let me see how these are held in. I see 3 screws. 1, 2, 3. They're around this transformer here. This is the output transformer. Now let's get those screws out. This is just to remove the lower frame so I have some maneuverability. Okay, so I'm going to lower it down. Okay, so now this can move around, which is important because I need to be able to disconnect 3 wires that are in here, and these are in the way, and I don't want to try to remove these if I can avoid it. So, let's see if that helps me get to those screws to disconnect the electrodes, the wires. Okay, there's one. One. Yeah, this definitely helps. Two. The third one, so I'm just turn this around to where my screwdriver can reach it. Now we are free. So they went to these 3 connections here. And now that leaves the trimmers here. And if I disconnect these screws, this lower set of the banana slicer will come out, I believe. I may have to do both sides. So we get that done, so we get that apart. Meanwhile, this is the way the rest of the chassis is doing it. I got the other screws here that went into the lower part of the tuning condenser. And here we go. Okay, that gives me something to start with as far as cleaning the chassis goes. But I'm going to work now on taking the tuning condenser apart a little bit more. Now let's see, I need to let's take these out here. The ones on the left have star washers on them. You know, the right way to do this is actually leave these in, because this side here you have a little bit of delicate stuff and I want to leave this stationary while I'm working on it. So let me go ahead and get these out now. Do you think it matters which one's left and right? I mean, number 1, number 2, number 3? Well, considering that the upper plates may have been bent to match for tracking on the dial, I'm going to assume it does matter. So, I could be wrong, but I'm going to be safe rather than sorry. So what I'm going to do is I'm going to label these so I can keep track of who's who. Okay, this will be number 1, is the one by the front of the radio. Let's see if we can figure out, does it come out easy or is there something in the way? Nope. Number 1. Okay, there's 1. 2. And number 3 is the one that's back by the back of the radio. It's also interesting, you gotta make sure you don't go in the wrong way this way, but the shaft will only align one way. Alright, got those 3 guys out. And here they are. And now we're left with the case. These are riveted. This is riveted, but I have the trimmer capacitors here, and so this will be a piece of mica in here, and I'd like to take these apart and clean them, but I'm going to have a fun time realigning this. It's interesting, the bottom of these screws, if you can see, has been soldered. You see that? See, it's soldered. That's soldered. Soldered. So you've got a nut, a top plate, and a sheet of mica, and that's the trimmers. And you could bend these to get these shields out, but there's no point in doing that. Plus, they're also riveted, so I'm going to leave them. Yeah, I need to take that out. I'm assuming the phenolic would be okay to leave, if I put it in a ultrasonic. But maybe I don't need to do that. Maybe I'll just clean it real good. Okay, so when I go to take these trimmer capacitors apart, I'd like to try to be able to get these nuts back to being close to where they were. So I'm going to use a trick for working on carburetors, as you know, is if you want to get the fuel air mix out, what you do is tighten it down, count the number of turns, that way you can back it back out the same amount when you put it back together again. Okay, so I'm going to be over, where's my thumb? Where's my thumb? Is that it? Hello? Hello? Okay, there we go. We got focus. So this is the number 1 capacitor that's up by the front dial. What I'm going to do is put this on here and count my turns to tighten it. Alright, so my X-light label is facing up. I'm going to go to tighten. It's about a half turn. It's a full turn. That's it right there. So that's a full turn and 2 flats. Full turn and 2 flats for this number 1 trimmer. Alright. So what we have here is we've got a brass nut with a split on the top for adding friction. Come on. Brass nut. And then there is a fiber washer underneath it. Fiber washer. Shiny side down. Then we have the top electrode of the trimmer capacitor. It's here. Copper. And then we got the little sheet of mica. It's on there. And I should have brought some tweezers. I need to treat this carefully. I don't want to get a crack in it. So I'll get the tweezers out and I'll get the mica off. And then I'll do these other 2. I'll come back with video so I can video how many turns I took on each of those as well. Okay. Alright. So come up here Focus. You see the little capacitor sheet there, a mica sheet there. I'm just going to see if we can carefully remove that. And there it is. All right. So we'll take the mica sheet for number 1, which came apart with 1 turn and 2 flats. And I'm going to keep these as matched sets just in case it makes a difference. I think it will. So I just want to be careful. Okay. Mica sheet. This. Okay, so there's number 1. All right, let's count number 2. Number 2 is going on with the X-Lite logo pointing up. Let's tighten it. Well, 1 turn. That was it. 1 turn. Two. Now 3. Okay. Slide logo pointing up. All right, it's a little bit to the side, a little bit to the tight side. That's okay. All right, let's count to tighten. Less than a turn. So the X-Lite logo is here. I'm short 2 flats, so I'd say it's 1 turn minus 2 flats. 1 turn minus 2 flats. All right. Fiber washer and top plate. There it goes. And mica insulator. There it is, 3. And I forgot to write on here 1 turn minus 2 flats. One T minus, is it 2 flats or 3 flats? It was 2 flats. 2 flats. Okay. Okay. There we go. We got those 3 done. Now, for the sake of keeping things together and making sure I've got all the pieces, I'm going to put. Well, let's see. I can't do it. Those 3 go there. Okay, so let's do it here. Just to make sure I just keep all the parts together. Notice there's no grommets. Alright, so we got those in, Okay, that's the tuning condenser all stripped. 50-50 water and simple green, it's hot water. And let's see what we get here. I'm just just want to get most of the loose dirt off here. Okay, this is the results from doing a cleaning with just simple green and a brush. Still some surface corrosion on here and staining, but it got most of the loose dirt and grime and stuff off of it, you know, like dust and stuff like that. See what I mean? Every time you make a clean spot, you know? Yeah, I've spent a couple of days on this. Have I worked full time? No. Who can do this full time? So, does it look beautiful? Yeah, it does. I got to do this face here. You can see where some of the stuff ran down the side. So I mainly I started off with soap and water on this, and then let me see, then I tried Mothers, and I didn't really get too far with the chassis. I saw where people have used CLR. I went after CLR and made a big clean spot right here, and then I knew I was in trouble because it kind of went, oh, it really kind of went further than I wanted to go. But once I'd done it, I kind of had to keep going. So I found I had to put the CLR on and let it just kind of sit there for a bit, and then it would kind of tend to go after the oxidation and whatever this top layer is. You can see, you know, this is, I believe this is probably cadmium plated, which is poisonous, of course, and I may be even through the cad plating here. And I don't intend to paint this. You know, it came out cad plated. I'm going to leave it cad plated. I'm going to use the probably use Bow Shield or something like that on here just as a rust preventative. But you know, cadmium prevents rusting. So I mean, if you still have cad plating, you probably don't need to put anything on it. But it'll go back to the way it looked like, and you know, that's what they would look like. So I mean, it is what it is. The case that had the original filter capacitors in it, you can see what it used to look like. It had kind of a, I don't know, maybe it's cad palladium on the outside, but it's pretty much gone, as you can see. I'm probably just going to paint this. I'll probably paint it black to match the transformer because it's right next to it. I'm not going to paint it silver. You know, if something's not silver and you paint it silver, you can kind of tell it's not silver. So I'll paint it black because it could have conceivably been painted black. So I'll do that. Meanwhile, I'm going to try to even this out somewhat, and then I'm ready to just about be done with this. The rest of it, we'll see how they're coming along next. Okay. Tag for number 1. Tag for number 2. Tag for number 3. And it won't wash off. Now I can go in the ultrasonic without losing its lettering, losing its numbering. Do the rest of these. And that's number 3. All right. Okay, then go in the ultrasonic without me wondering which number was it before the marks a lot or the Sharpie washed off. Okay, let's see how this masking job turned out. Otherwise, I'll just take the tape off and paint the whole thing. So let's just see how we got here. Alright, I think that looks pretty good. Let's see how the other side turned out. Alright. Alright. That looks good. I'm satisfied with that. That looks fine. Okay. Yeah, it's time for my old Harbor Freight cleaner to get retired. I had problems with the button. I've had this thing for, I don't know, 15 years. The membrane buttons don't work anymore. Now, the fact that this was underwater for a couple of weeks, don't let that bother you. But anyway, I could have gone in here and maybe tried to fix this, but it only goes up to a certain amount of time, and it's kind of small, and I decided I wanted something new, so this has been retired. Bye, old friend. I'll take your cord. Yeah, this is my new one. This is a 10 liter. I just wanted something that had more size and more room. I may fix that Harbor Freight one up for when I need small pieces done. Okay, everybody out of the pool. I've always done it this way where I put the cleaner and so forth in a Ziploc bag, and therefore I keep the the bowl of the ultrasonic cleaner. And I'm going to pull these out and get them rinsed off, and we'll dry and we'll see how they look. Okay, so I'm starting to assemble the trimmers back into the position. I've got the first one on here, and I thought I'd show you real quick what I did for this, just so you can see. So what I do is, this will be for this trimmer number 2, right? And what I do is I use alcohol on the mica, and then I put the metal pieces and the fiber washer into the ultrasonic cleaner with a little bit of simple green is what I'm using right now, just some kind of cleaner, and then go after and clean them up. And if it needs a little bit more brightening up, I use a fiberglass brush to shine it up just a little bit. Don't need to do much, just make it look nice, but mainly make sure these are clean, don't have any chunks of anything on there that have any interference with setting the capacitor. And then put it back together. And then what I'm doing is then I'm not going to make these tight. I'm going to leave this kind of loose so that when I put this in and I adjust these screws, I can make sure everything's seated straight and so forth. And then what I'll do is eventually take these and I'll tighten them down, not tight, just till they touch, right? And then go back into my list of, this one turns plus 2 flats, get that backed off of tight that much. And then I think I'll have this set pretty much where it was originally. Of course, it'll all have to be realigned, but I'll do that once I get everything put back together again. Meanwhile, I'm going to go get back to working and getting these pieces in, and then we can look at putting the top piece in and then securing it with the clips. And that'll be the assembly of this until I can put the dial on the front and so forth. So I'm going to get started on that. Not that it really matters. I'm just using alcohol for this. Mainly it's just dust, seems like, on this. So that's it. So I'll just go around the rest of this and clean all this dirt off of it, and it'll look nicer. So there's 2 little raised places that go on either side of the fiber washer that kind of holds the copper top plate in position. And that spins down until it gets to the split, which is crimped in a little bit, and then we start getting some drag on this. So now I'll run that in until it bottoms out. Not tight, just until it touches. That's good enough. That's just kissing the bottom. Okay. I'll get the last one in and we'll put the bottom pieces in next. Okay, we got all 3 in. Now start time to put the lower pieces of the capacitors in. So set that aside, and that aside. I've run them all the way down to where they're touched, but I want to loosen them up now so that these plates here can float a little bit. The way they're aligned is you've got a focus, you get a fiber washer there, and it's got a fairly snug fitting focus. You get a fiber washer there that's got a fairly snug fitting center hole that aligns on the threaded shaft that's coming up from the lower plate. And as it goes through that hole, it then centers that washer, and then there's two little tabs that are on those copper top plates that align up with the outer circumference of that, and that actually gives that copper plate a little bit of positioning. And then as you can see, the holes for threading in are slotted, so it has lots of room for moving around. But what I want to do is I'm going to just loosen these things up so it can find its happiest center when I go to put those lower capacitor plates in. So I'm going to get them in now. So first thing I'm going to do is I'm going to loosen these up so they can float. That's enough. Enough. Okay. Let me get the hardware for these. I don't need to, the hardware's right on them. Okay, so here we go. We're going to take, this is number 1, right? Cut its tag off of it. Okay, see if this sits in there nice. This has got nothing in there. Okay, looks good. Little phenolic wafers are just kind of flexed in a little bit. Get it nice, nice and straight. Okay, I want to get these started on this side here. Okay, now this one looks pretty well lined up. Now see, this copper plate can pivot around a little bit. That's good. I want it to be able to do that. Okay, so now I'm just going to take it easy here. Let this thing kind of find home. Not doing one side more than the other too much. You see what I'm doing? Okay, I think I'll go ahead and snug this. And there is one back in. I'll get the other two back in, and then we'll start to go from there. Put the top plate in. That's looking pretty nice, I think. Right, so you learn by doing, right? So what I did was, before I got the second one in, and then I thought before I go any further with putting the third one in, I was noticing that these move around some, and so what I thought, well, let me just kind of make them uniform so I know what I'm doing. So what I did is, when I loosened these back up and I pulled these up as far as they would go, just up, okay, to see, I figured that'd be, see if it clashes or anything. So then I'm taking the top part of this, I was just doing a test fit of it, and I'll show you what I found. I put it in here like this, right? Then it lands in this cradle right there. Okay, that's the position. It doesn't want to move. Now if I bring it down, I don't know if you can see, but like if you look right here, it starts to hit. This one's not too bad, but this one's already trying to short. So what I'm probably going to need to do is I can go ahead and put these in, but before I snug them up, I need to go ahead and get this totally engaged and then tighten them up where it looks like I've got them in the center. So I'll go ahead and put the third one in, then I'll loosen these up, and then I'll come back and we'll start to see if we can center these up some. Just have to eyeball it, looks like. Had to go to a different screwdriver. I didn't want to risk rounding these off. This is a screwdriver set I got many years ago. Anyway, you can see that they're flat ground. They don't come out as a taper. So you get the right size and it just slips right in, and as you turn it, it doesn't want to cam out. All right, put the third one in, and then we'll look at doing the alignment of the bottom pieces. And so here's number 3, going into the third spot. When we get it in, we'll come back. Okay, so we got it all starting to be assembled. We know now that there's going to be a little bit of trickiness here. We got to get straightened out now. But that's the trimmer side. You get a good look at the trimmers here. We'll be adjusting those later with that plastic tool we made in the part 2. All right, and so here's the other side. And now what we need to do is put the upper part of the capacitor in, and then see if we need to adjust these. I know that we need to where we can get it best separated and aligned. So we'll do that now. And I guess I'll go ahead and put the spring clip in as well. Alright, so here's the upper capacitor. I'm not doing anything about where the rubbing has been other than just make sure it's clean. Focus. Okay, so let's put this in and we'll put the plates in. So I need to open it up. It's going to stick into this hole first, and then slowly lower it down because we know there's going to be some clashing. Okay, it's in position. As I bring it down, I know it's going to touch, but I don't feel it. It must be dragging somewhere. But I'm going to set it down like this because otherwise it's going to slam. Okay, so now we're going to put the springs on. This one goes in the underneath. Get this cleaned up and looks nice. Okay, so it goes in. It's going to hook on here, and let's go up here. So let's put it through here. Bring this end up like that, and now this end comes up and goes on there like so. Okay, didn't think I could do that with my fingers. Wasn't too bad. Okay, back one's in. Let's put the front one in. The front one, there's several holes here for tightness. Sorry. There's several holes here, but I know that it was in the front one, the top one. So this engages, let's see, how was it? This, so it goes in like so. Like that. It turns over, goes across the top, and then goes into this hole here on the side here. There. Okay. I'll get to where I can see where I'm pushing. Okay, that's in position. Now we'll turn. Now it's got drag on it. Oh. Okay. Okay, now I can definitely feel it dragging all over the place. So let's do them one at a time. We'll see how it goes. It's hard to know which one's dragging. You can hear it. What I'll do is use continuity. Let's go ahead and loosen them up and just see how it behaves. These trimmer screws are still loose, these nuts. Okay, so this should move around a little bit. It does, okay. I feel dragging over here. But this one looks okay. I gotta loosen these other ones up, it's dragging. You see me making the adjustment right here? It looks pretty good on this side. I'm sure there's a fast way to do this. By the time I do the third one, I'll be faster. Oops. All right, let's see. May have just messed it up. But let's just see how this is coming along here. A little harder to see here. So let me start it over here on this side, right? Maybe just do it fully meshed. All right. Yeah. So now I can kind of see the whole thing all at once. That looks pretty good. Is it moving? You're not telling me. That still looks okay. Okay, what about on this side? It all looks there. A little bit better there. Let me tighten that up. I'm taking a look at it. And of course, one of the things we got to do is make sure we don't have a short. So let me hook up a tester. Now on this side, I should be able to clip onto this traveling piece. I can pick it up here, right? If I go into one of these. Let's see. Okay. So as long as that's there, then if these pieces short, okay, so if they're touching, we'll get a beep. Okay. Okay, so it's not touching anywhere where that is right now. So as long as I'm satisfied that it looks like it's reasonably centered, I can go ahead and tighten it a little bit more. I've got it tightened pretty good, because that test would have been not much use. So I'll go ahead and tighten it up. Let's go to capacitor 2. I like it this way, so I'll go ahead and close it up, and then you can eyeball it and get it close. And then start snugging it up, and then test with the continuity. I had to turn my music off on doing this because I didn't want to get a copyright strike, but I was listening to one of my favorite albums, and as I was putting this together, I could hear Maynard chanting, "I know the pieces fit." Yeah, I was listening to Lateralis. Okay. How's that look? I think it looks okay. Okay, we'll do our short test. Here to here. Red lead I'll put onto here. And we'll test. Make sure this thing is working. Okay. Okay, note short. Double check the alignment, then tighten it down. Looks good. See right there? And there. Looks pretty good. All right, let me snug it. No. Okay, do one more. I'll do one more trip through to make sure I don't have a short on any of these since they've all now be tightened, but they'll look good. Let's look at this one here. Let's look at this. That looks nice. Looks good. Let's see this one. Looks good. Comes up here. Yeah. Looking pretty nice. Okay. Looks good. Okay. The rest of it has to be adjusted with these guys, I guess. All right. Looks good. That, the pieces did fit. What do you know? So what I'll do is that I guess I'll do it now. Because what I'm going to do is when I put this thing in, I will take each of these and run them down till they just kiss. Not tight by any means. How about there? So that then when I get the thing, well, I can do it now, I suppose. Then I know I'm done. So I drive each of these down until they just kiss. Right there. And I know I'm still going to be off a long ways, but this is just to get it close, right? So then when I do the alignment, I shouldn't have to be hunting around quite so much. Now in some cases they say what you do is you want to make them all so out of whack that you can always hear one, and then you do the next one, then the next one. For the version of this radio that has just two of these, that's one of the things they do is they say pull one of these out that's so far off that's not even in the ballpark in terms of how this is oscillating. And then when you do the next one, then when you bring it in, then all you're hearing is the results of the oscillation of one, and then you go back and do the other one. When it does the three, it didn't really say that. It wasn't really clear to me that you do it that way. And when I did it before on testing out the equipment in part 2, I didn't bother. But in this one, if I have any difficulty bringing them in, I may do that. But anyway. All right, so let's see. Number 1 was out 1 turn plus 2 flats. So we'll do that now. Go in, back you up so you can see. No, there's a label, you can see it. All right, so there is out, let's see. Okay, we're about perfect right there. Okay, 1 turn and 2 flats. Here we go. 1 turn, 1 flat, 2 flat. That's where that was. Okay, number 2. Number 2 was 1 turn even. Okay, that's it right there. 1 turn even. To there. Okay. Number 3. 1 turn minus 2 flats. All right, so here. Okay, 1 turn minus 2 flats. So we go, get that again. Right there. Okay. 1 turn minus 1 flat minus 2 flats. Okay, those should be set pretty close to where it was before. And now this guy is ready to go back on the chassis when we get to that point. There it is. I left that in. A maker did that, maker mark. Probably some lady did that. That was her number. I like her too. There's 7. That's pretty clever. Anyway, I left it just like it was. And I'll put some grease and so forth in here a little bit later. I don't want to mess with that right now. And then these are the ones that hold at the bottom of the chassis. Nice and clean. Okay. Fantastic. Alright, I've got about as much cleaning as I'm going to be able to get. You know, there's always a problem trying to get uniformity, but it looks pretty good, I think. Looks nice. And I'm going to call it good enough. I can see why people paint these, but I'm not going to. Not this one anyway. Alright, I'm going to go on with Bow Shield and just see how we like it. Now, let's talk about what we're looking at here. So we've got areas where we've got CAD plating over steel, and there may be various thicknesses, and the dripping was going a certain way when it came out of the vat and all that good stuff. But where the cadmium is, there really isn't a need for this, except that what happens is that the cadmium will oxidize and change color and turn that dark color that is less appealing to people, of course, as opposed to looking brand new like this, right? And but has CAD plating do what it does? Well, CAD plating is a type of galvanic corrosion protection. And nowadays, when you buy galvanized products, galvanized steel, you know, it's been coated in zinc primarily. And that's because if you look at the kind of environment these things are going to be exposed to, it's typically an environment with water vapor and moisture, condensation, and so you get water, and then you know it gets mixed with other impurities that are here that allow the water to have a little bit of conduction capability, maybe a salt or something like that, and then that means the water can be conductive. Now, if you have dissimilar metals in contact electrically with each other, and they become connected by a liquid such as water that's got salt in it, or an acid, that kind of thing, now what happens is that you begin to get action that's like a battery, a galvanic action that creates like a battery. So if you remember about the old lead acid batteries you had in cars and things like that, you would have plates of different materials in a bath that was designed to be very conductive to electricity, and that is usually an acid, right? Battery acid. So it's very conductive. Cadmium does the same kind of job that zinc does in those days, but cadmium is what they used. I don't know exactly why, but they quit using it. I don't know why they quit using it. However, it's good that they did, because apparently it's got a high degree of toxicity, whereas zinc is much less, much less. And you can hot dip it and all that kind of thing. It's kind of interesting if you look at zinc, like galvanized telephone poles and things like that, they sometimes will add something to them so that when the zinc solidifies, it forms crystals like metals do, if allowed to, and they're so large you can actually see the crystals. and because the electron planes set up in different positions as different crystals are formed, you get different reflection off of each. And so when you look at it in sunlight, they look like you can see the different grains, and each grain has its own pattern and it's tipped that same way, and you can see it. Normally in metals like steel, that has steel's an alloy, of course, of iron and carbon. The grains are too small typically to see. Look at them under a microscope, and you can see the grain structure. And the grain structure will tell you a lot about the strength of the material, the way it's been heat treated, the way the grain boundaries set up. You get different types of strengthening mechanisms: cold work, precipitation hardening, just plain alloying, plain different alloy compositions to get different strengths and give different amounts of ductility, toughness, that kind of thing. So I'm going to show you real quick. I've got kind of a quick coat on this. I'll probably get some more on here in a minute. I probably found I missed some places, and I'll do some more in a minute. But I'm going to describe for you the process by which cadmium or zinc protects steel. So hang on a minute, let me get this all out of the way, and I'll show you. Okay, let's talk about corrosion mechanisms for just a minute. Okay, so one of the things we look at is we look at how steel rusts. Okay, now what's great about steel is steel has great structural strength. This chassis is made of steel because we need the structural strength. So steel, which is an alloy of iron and carbon, is a very desirable material for this sort of thing, sheet metal and so forth. But it has downsides. What is it? Well, the iron within steel will rust. Okay, and rust is bad, right? It causes the steel to lose its material, and it becomes weak and gets holes in it and falls apart, and it's an eyesore and all of that. Okay, so we like other types of materials, don't we, that don't rust? Cadmium, right? Aluminum, stainless steel, other types of materials, because they don't rust, right? Well, they do. Rust is a type of oxidation process that we don't like, and it turns brown and it causes things to eat away, and I'll talk more about that in just a second. But you know, the oxidation also occurs with cadmium and with aluminum and with stainless steel and so forth. So you know, zinc. The difference is what we think about the oxide that results. What about what happens to brass? What about what happens to silver? You know, in that case, we see the oxide layer, but that's called tarnish. The difference with iron rust is that the compound that forms up with the iron and the oxygen forming together, that compound is not stable. It doesn't want to stay as a film. It crumbles and falls off. It's an interesting fact that and there's various different ferrous oxides depending on different chemistries that happen, and without getting into all that, whatever compound is formed, it actually takes up more volume than the iron that it displays, so it actually makes it puff up and fall off. Okay, and then once it does that, it exposes fresh iron for the oxygen to get in there and attack it, and of course water will accelerate that, and so that's what rust is. But the thing to know is that metal is all oxidized, maybe with the exception of gold, to be, you know, pedantic about it, but they all oxidize. And what happens is that the oxygen goes in and binds up with some of the alloying elements or the other types of elements that are there, and it forms a passive film. That oxide layer is happy to stay in place. It stays bound on, and it allows the oxygen to penetrate into the surface just a little ways, and then it stops, and you're left with an oxide layer that protects the layer below. And in the case of stainless steel, it's pleasing, it's shiny. In the case of aluminum, you know, it's shiny. Now this is shinier because I've polished it. I may have removed some of the oxide, but it's going to eventually cloud back up, just as your silver, you know, your wife's tea set is going to start turning a tarnished color, and it has to be removed from time to time. But generally it protects the surface, and this cadmium has an oxide layer on as well. Now I have removed a lot of it. the layer that forms is kind of that yellowish dark color that's not that appealing, and it gets dirt stuck in it and all that kind of stuff. So we got that all cleaned off, and it looks okay. We're going to keep this, bow shield on it, but it would have been fine just to kind of leave it alone. Okay, so we've talked about general corrosion. Okay, now let's talk about other types of mechanisms that take place. I talked a minute ago about galvanic corrosion, galvanic action. A galvanic cell is a type of battery. Car battery is a galvanic type battery. You've got plates of different metals of different types, and they're in a bath of battery acid, and out of that you get electricity out of there. Okay, so let's talk about what that does, how that happens, and we'll see how that applies to what we're doing here. And I got another example to show you that made me think about doing this. So let me get on that. So bear with me a minute. I won't make this too painful. Okay. Let me just say, let's assume that we have a metal, a surface here, and let's want to have two dissimilar metals. Okay, dissimilar. They're not the same. So, one of them's like this, the other one's like this, and the main point is that they are electrically connected together. Okay, they're butt up against each other, or one is coated on top of the other, like we have here. I'll get to that in a minute. Okay, and then we have this in the presence of, let's say, an electrolyte. All right, so let's go with something common, what we're usually used to. So let's take some water, H2O. Now, get the focus to work here. Focus. So water, will dissociate. It self-ionizes. And what you'll get is a hydrogen ion plus the hydroxyl radical. Okay? And this right here will want to go after the metal, okay, that's here, okay, because this is a negative ion. It's a negative ion. It wants to pull the metal out. And so let's say that this is cadmium, and let's say that this is the iron in steel. Remember, steel has a little bit of carbon in it, and various other things. But anyway, depending on the grade. So this is going to try to take a piece of metal off of here or off of here. So which one is it going to do? Is it going to do it equally? Well, it just so happens that based upon chemistry, that in the presence of different types of electrolytes, these materials may be more or less anodic and cathodic to others. So there's a table, you can look it up. There's a galvanic chart that would be for dissimilar metals in, let's say, a water solution. That's the most common one you'd see anyway. And we have cadmium that's on this chart. And the higher you are, the more active it is, the more of an anodic it wants to be. And iron is down here below it. So that means that cadmium will want to be the anode, and iron will want to be the cathode. So what happens is that because this is more active than this, then this is going to say, I'm going to take a piece of metal out of the cadmium. So let's say it comes along here and takes a bite out of the cadmium right there. Okay, so what it does is it pulls, let's say we're going to pull a metal atom out of there. And I'm just going to abbreviate it M, because as we use different metals and so forth, it'll be different atoms, and it'll be different stoichiometry depending on the chemicals. We don't need to get into all that. This helps us just understand the overall process of what's going on. So it pulls a metal ion out of here, and when that metal comes out, it releases an electron to now be free inside of here. So now that electron comes out and it's ready to move. Okay, it can move and go booking along this way, for an example. So what you've got is that you then have this metal and this OH come together. You have metal plus hydroxyl radical, then leads to basically MOH. Okay, MO. So then what happens over on this side? Well, here the hydrogen ion comes over here, and here comes our friend the electron, and the electron's coming up over here. Okay, so let's look at it this way. Let's say we take two of these hydrogen ions and we combine it with two electrons, and what that does is it leaves you with a hydrogen molecule, H2. H2 is a gas, so what happens is you get bubbles forming here, and the bubbles evolve off. So you start getting bubbles forming over here, and they start bubbling up. And if you've ever seen a battery being charged, you've seen the bubbles coming up out of it, like a lead acid battery. Okay, so this is a mechanism that causes an accelerated type of, it's an additional way of causing corrosion to happen other than just general corrosion. By the action of this battery, it creates more corrosion you might otherwise have. And so once again, if you had it to where these were two separate pieces of metal and you connected them with a wire in between here, then you would have current flowing through here, and there'd be a potential here. You'd have multiple plates to build up the voltage, and you could have, depending on the areas, you could have more and more current going through here, and you could use it to power batteries, you can use it to power lights, you could use it to start over your starter in your car, whatever. This is the basis of the principle of how that works, okay? But this isn't how we're using it in this case, right? So what we do is we try to use this principle to help us out. And one of the things you'll see is that you don't want to have an area where, a situation where you have as much surface area here as you have surface area here. So what we'll do is that we'll go in and we'll say, well, here's our base metal, and we want to use steel, which is mainly iron, and with other alloying elements, because it's strong, but we need to protect it because iron likes to rust, and we don't like rust, okay? So what we're going to do is we're going to put a coating on it, and this can be cadmium, or it could be aluminum, and it could be zinc, okay? These are other types of, and by the way, they're up here. They're even better than cadmium in a lot of ways. And so you'll see nowadays that we don't use cadmium. We'll use aluminum and zinc and so forth as this coating on here. Because what it'll do is it'll protect it because it's an anode. So let's take, for example, that we have this coating on here like we have here. And what will happen is that the cadmium protects the iron from being exposed to the elements, and so now the iron won't rust as long as the cadmium's there. Cadmium will bond to it, it'll stay there, and it protects it. It'll get a little bit of surface oxidation on it, and as long as we don't keep sanding it off by trying to make it look shiny and pretty all the time, it'll stay there, okay, for a very long time, unless something else happens. Now let's say something else happens. We get a scratch, or over time it was maybe a thin coating, or maybe something happened to it and you start to get a hole in there. Let's say something like this happens. So we now have like a scratch in the cadmium. All right, what happens is you go right in here and you look at it really, really close in here, and what you've got from here to here, if you're inside this groove and you're looking at it from here to here, you see this going on, okay? And if you have like a surface layer of moisture in here, now you can have this sort of action start to happen. So what will happen is the cadmium will give up a cadmium ion. The iron will give up an electron because the electron comes around this way and gives the electron up, and then you'll get this falling out here. And actually what we have here is we'll then have 2M plus 2OH then leads to 2MOH, right? Then we start having this kind of deposit that falls out, and it can even, if you have a situation like here, it can actually build up inside of here and heal itself. Okay, that's pretty cool. Now if you have this in a bath, aquatic bath, then it won't be focused in right in here, but what you can have is the cadmium will still want to then give up itself, and then the electron will come in here, and you'll just have hydrogen bubbles coming off of here, but the cadmium will protect it. And because you have such a very small surface area of where that electron current is, it causes it to have a restricted current density. And if you spread that number of electrons across all this cadmium from metals being pulled out, this mechanism is not driving very much activity on here in addition to what would normally be happening. So the cadmium would be protecting the iron, okay? So that's if it's in a total bath, all right? So you can take that same basic idea and say, well, we can use this other ways. The cadmium doesn't have to be right on there. Let's say, for example, we have a boat. The boat has a motor on it, and the boat is meant to be in water. And below the water line, you may have an anode bolted to the back of the motor or on the side of the motor. You may have anodes on the boat, on the side of the boat. And the boat is then coated with paint. And the idea is that the paint is covering the iron, and if it gets a scratch in it, then what happens is the scratch is in the paint, but there is a wire, or it is electrically connected, because you come over here and the anode is welded to the base metal, and then the anode sacrificially corrodes, gives up itself, provides electrons into here, and the electrons travel through the steel and go to wherever the scratch is, and causes just a little bit of hydrogen evolution there, but it doesn't allow the seawater to attack that scratch. The anode saves it. That's what they call it, a sacrificial anode, and you find this all the time. You'll see it in like buried pipelines, and they'll put either an anode off to the side and hook it up with a wire, or even they impress a current in there. That's called cathodic protection, and it's the same basic principle. All right, now I want to show one more thing real quick, and that kind of what brought this up. What if we did the reverse here? And that does happen, and I'll show you an example of that in a minute. So let's say that we have our base layer, and we have a coating on top. And let's say our base layer is iron again, or an iron alloy. But let's say that we want to put something on here that looks really shiny and pretty and all of that, like a chrome bumper. So we're going to plate this with chromium. Right? Well, where's chromium? Chromium's down here. So what happened is now what we've got is where we had cadmium was the anode compared to iron. Now what we've done is we've flipped it. And now iron wants to be the anode to the chromium. So this all looks really nice until you start having some problems happen. So let's say you have a divot like this happens, you scrape up against something, and you get a scratch in your chromium, where it just finally happens over time. There's pinholes through here. They call them holidays. I don't know why. But say you get a little scratch, what happens here. So now this battery cell is reversed. Okay. So now what it wants to do is the iron wants to give itself up to protect the chromium. So what you have is in here, where that little contact area is here, the iron is being stripped out this way, and the electrons are going back into the chromium, and now the chromium is allowing the bubbles to come off this way or escape through here. All right, so what it does is it starts to peck away at the iron underneath here, and it starts to, remember, it wants to travel along the connection. So what it does is it travels along underneath the chromium, and it starts to rust and lose iron and so forth, and it starts to bubble up, and it actually pushes the chromium off the top. It'll actually cause the chromium layer to just get stripped off. Now guys my age, you know, we used to have chrome bumpers on cars all the time, and after a period of time you start seeing little bumps and all that. You try to polish them off, but they're always still there. You know, he's talking about polishing them with aluminum foil. But anyway, eventually what will happen is that bumper will start to corrode, and it'll peel that chromium right off of that. And that's why you don't pay attention to what you put on top of other things. So let me give you an example of that. What made me think about talking about this was I've been using these acid brushes, right? These are just these little cheap brushes that you use. I've been using this to apply, you know, the evaporous gel or naval jelly or the CLR, whatever I've been using on this. And it's got like a little very thin flash chrome coating on this, okay? I think it's just very thin sheet metal, steel that's rolled up and is flash chromed, okay? Well, that seems to work all nice and good, and while it's there you can wipe it off and all that, all's well and good. But I had one of these. This was sitting next to my sink for a period of time, and from time to time, you know, it's kind of a wet, splashy area, and I just kind of forgot about it. And so over a period of maybe, I don't know, a week or two, what used to look like this now looks like this. And so this is an example of this reverse thing, where you have iron alloy, steel, underneath the chrome. And what happens is it got underneath there and started peeling the chrome up. The steel is being the sacrificial anode, trying to protect the chromium layer on here, but it's going underneath the chromium and causing the chromium to pop off. And then this is what our bumpers used to look like before they were all turned plastic. So that's why it matters when you're doing, you know, galvanic protection on things like this, which is which and what alloys you use. Nowadays we use zinc primarily. You hot dip it, works great, lasts for a long time. And anyway, I just thought you'd like to know a little bit about that if you didn't know. Anyway, let's get back to what we were doing. Okay, so I'm going through and just verifying the performance of the transformer. Since we did the wiring up of it on the side, I've got voltage running into it coming through the variac. I've got it going through the isolation transformer dim bulb. I'm watching for current, doing everything you can do to try to make sure everything's okay on this. And I'm going in about 70 volts here, and the high voltage between pins 9 and 12. I'm currently at 440 volts. I don't need to go up real high. Just verifying that everything seems to be okay. It's nothing getting hot. There's no current going or white array or anything like that. Everything's looking good. Anyway, I'm just going to keep going with this, but I don't expect any issues, and then I'll be able to start wiring up the chassis. Okay, so I'm doing a little bit of a test fit up here before I bolt all this down. I'm thinking about putting it back together in basically the reverse order which I took it apart. The biggest issue I'm going to have is rewiring the transformer, and so I don't want to have too much on here before I go to attempt to do that. I think I'm also going to not have the tuning condenser on when I'm doing all of that, so I don't endanger messing up anything that we've been working on here. This is a fairly delicate thing, right? And this is just set in place. I'm not going to strip off this old oxide coating of this. I don't want to lose that. It's just too much of authenticity. All right, what I need is a couple of holes that I want to mount, use for mounting the fuse holder, and I don't want to drill any holes in the chassis. If someday somebody wants to restore it without having a new looking screw in there, that's fine. They can take it out, and there's no holes that were added in the chassis, so I didn't damage or deface it in any way. I think there's 3 holes here that don't appear to be used for anything, that are near kind of where I need it. Here's where the power cord is going to come in. So I'm thinking about utilizing some of these holes in here to do that mounting on the underside. So I want to take a look at that, and then that'll be the plan for that. And I think the next thing I'll do is go ahead and put this on to get it out of the way, because I need to use those 2 screws that are here that I use for mounting the capacitor replacements for this. I need to go ahead and get those in so that I'm not trying to work through those. And then I think what I'm going to do is put the fuse holder in, and I'll decide when I get to it, but I think what I'll do is wire from the fuse holder to the switch and and then be ready to do the transformer. Then put the transformer on, and then I'll be wiring that top layer of connections, which is 1, 2, 3, 4. 3 and 4 are the power connections. So I'll be working on 1, 2, 3, 4, and then have the power switch in and start working my way down. And that's going to be the most tedious, because I'm going to check every connection. I know that I numbered everything, but I'm just that way. I'm going to verify by looking at the schematic that each wire is going where I think it's supposed to go in the circuit, so that I just feel confident with that. So then that's the plan. And then when I get done with that, I'll put the tuning condenser on, and then maybe we'll go in and start trying to see how the alignment sounds. It's going to be off, so I get that realigned and all of that. So that's currently the plan, and we'll get started on getting the wiring done. It's going to take some time. Okay, I've been chasing continuity of all these to make sure I know that they're all hooked up to the right place and where they're going. I need to double check where this pigtail went, because it's been a while since I took it off. It goes right here. And what I'm going to do is I'm going to replace this wire. This is really crumbled up. I'm going to go ahead and solder it to the transformer before I put the transformer on, so I make it easier to pass through and hook up into here. So that's terminal 5. That was the one I had to cut off when I pulled the transformer off, and to reach in there and cut it. It was this one. All right, I'm going to get that new wire soldered onto here, and then we're going to put the transformer on, and then I'll start wiring all this back together, taking my time. Okay, we're making some progress here. We've got the power switch in, transformer on, capacitor on. It's not connected anymore. I got a new power cord on here. This is one of those reproduction looking cords. It looks very much like the one that was there originally. In order to keep it looking the same, I kept the same grommet in here and did it the same way. Tied a knot here and tied a knot on the inside. So that is still hooked up exactly the way they had it before. Alright, so what we can do is we can take a look at the underside. I still haven't put the tuning condenser back on, as you can see, but it'll go there and fit right in. but what I thought we'd do is take a look at the underside and see what we've been working on. So let me get this flipped up and we'll take a look at what we've done here. Focus. Okay. So we've been busy. We got the power cord comes in. Power cord goes first to a fuse. I currently have a 3/4 amp fuse in here, which I think is enough. Slow blow. I can put a 1 in there if I need to. I've got a CL90 thermistor here that will help with inrush and also drop the supply voltage from about 120, 123 volts, whatever it is we normally have here at the house, down to more like 115 or so, which is what this is looking for. That'll save the tubes from all that inrush current. Then we have from the line from the thermistor goes to this terminal strip that's here. And I also have the neutral lead come over to this strip as well. And then the hot and the neutral, after the fuse and after the thermistor, are twisted as a pair, come up here to our repaired switch, which is installed. And then we come over and attach to the transformer. The transformer has all been reconnected and the contacts scrubbed. Some alcohol to get the flux off of them. This is the pigtail that was underneath. It used to go to this location. It wasn't looking too good because of all the stranding that's in here wrapping around that. And you know, when you're soldering with stranded wire, it seems to be really kind of takes a lot of heat. And I just didn't want to put a lot of heat on that connection. So what I did was I went in here with a piece of solid core, attached it to here, and then brought it out and hooked it up to that multi-strand and then shrunk wrap it. I think that's a better way to protect that connection. I also replaced a couple of other wires that were back in here that went behind the BC resistor here. Somebody asked about that. That's basically like a can dome. It's used to give you different pull-off voltages. It's a big divider. Here's the original filter capacitor back in. It's just there for looks. None of it is connected. Here's the replacement filter capacitors that we put in part 2 that you all saw. I had to pull them out in order to disconnect it because it's part of what holds this on, but we got that reinstalled and reattached and all that. It looks good. Okay, so then what we'll do is we'll just verify what we've done with the cord. Now the cord is a polarized cord, which of course this radio did not have a polarized cord originally. So what did I do with it? Well, it does have an isolation transformer in it. So as far as the transformer goes, it doesn't really care, but I do care that I want the hot to go to the fuse first. So I've got the narrow blade here. If you can see that here, that's the narrow blade. All right. And so just to test it. Okay, so then this is indeed the hot lead. It goes to the fuse, comes through the fuse, goes to the thermistor, and then it stops through the thermistor because the resistive load on the thermistor until it gets hot. So then what I'll do is I'll take from that point, and now I'll jump over to comes here to the switch here. Oh, let's see a little bit. Comes here to the switch. The output of the switch comes here and goes to this terminal right here. So I'll just go on to here. And oh no, I don't hear anything. Let's turn it on. There we go. Our switch is fixed. And now our power works correctly. So the hot lead comes in, goes to the fuse down here, then goes to the thermistor, then goes to the switch. And then from the switch, it then goes to the transformer. And we should be able to see that the neutral lead to the transformer comes down and goes to the wide blade here on the cord. There we go. All right. So what we can do is, I don't have the tuning condenser back on yet, but I'm thinking about, since I don't have any of the tubes in, is I can kind of do like we did originally and just kind of start easy, right? And not put the rectifier in, leave the rectifier out, bring the voltage up on the transformer, and then just make sure that I'm getting good voltages and that all looks right and all of that. Then I'll put the rectifier in, and then I'll verify I'm getting voltages to the right places, Maybe put the rest of the tubes in then and see how they all do like they're supposed to do, and I'll be monitoring the voltage and the current and all that kind of stuff. I may show you a little bit of that, but not much, because it's pretty much what you saw in earlier parts. But before much happens, I'm probably going to need to get the field coil speaker back over here and plug it in here, so that I have part of, it's part of the power supply too. So make sure that that is working correctly and so forth. So next thing we're going to do is leave the rectifier out, and we'll start hooking up power to the power supply and verify what we're getting out of the different windings. So hang on a minute, we'll get onto that. Okay, so we're all set up to start doing some voltage tests. The rectifier is not in, and neither any of the other tubes. Okay, so we're just going to be doing a power up check of the transformer for the first time since we took it apart and put it back together again. I did some earlier voltage checks, but I'm just going to verify we're getting things kind of to where they're supposed to go. It's just, I'm going to do it step by step to take it careful. So the 80 rectifier is not in, and the field coil is not in. The filter choke is in, and all of this is there. The field coil is not in there. So I'll see if I can check some voltages just to see if we're getting something in some of them. We won't be able to get it everywhere, but it'll be something to be the first step. And if there's something wrong, it gives me a chance to catch it before I put a bunch of other things in and maybe cause current to run somewhere I don't want it to go. So the way we got this set up is I'm going to be measuring input voltage here. I have a isolation transformer back here. I've got a dim bulb that's in. I probably won't be seeing much on it. I've got the voltage I'm going to vary with a variac. Here we're going to be able to monitor the amps going in. Full scale is 1 amp. I expect to be, when the thing is actually operating, be around a half amp. Like I said, there's a fuse in here that now is about a 3/4 amp fuse. There's a 1 amp fuse on my panel back here. I got a lot of protection on here. All right, so there's no conductors in the back of this. I've just got it leaning up here so you can see it. And we'll start checking some voltages over here. So let's get started. I'm going to start off kind of low, and let me go ahead and just put the voltage on the meter on the high voltage circuit. Let me go ahead and get some things connected to the high voltage side, just kind of get an idea where we are. So we want 9 and 12. So here is, let's see, 9 is back here. That's kind of why I want to do this before I put voltage to it, to reach in there. And then 12 is here. So yep, 9 and 12. This way we'll be able to see what we've got on the high voltage before, because there's no load on this. So I really don't want to exceed too much there. Okay, this will be just monitoring what we have there for now. You see it okay? All right, let's go. Voltage is down all the way. Here comes the power. And we'll see if this is all hooked up right. I am going through my power cord. Let's see, power off. Switch is on. Okay, power on. Here we go. We're already getting output. That's 10 volts in. We're getting 60 volts out of the high voltage. Nothing moving on the amps that I can see. There's 30 volts. All looking okay. We've already been here with the transformer. I just want to get up to a reasonable voltage here before I start checking other things, just see if everything looks okay. Alright, so there's 50 volts. 300 volts at the between the high voltage leads going into the plates of the rectifier, which is not in. 60 volts. Not much happening. Still don't see anything on the ammeter. There's 70 volts. I'll probably go to 90. And there's 80 volts. Seeing a little bit happening on the ammeter. This is all pretty much just reactance. And there's 90 volts. We have 530 volts from here to here. Okay, that's a good place. I'm going to stop there and do some checks. So what I'm going to do is I'm going to kill the voltage, so I'm going to go ahead and pull these out, not risk getting nipped. Turn that off. So now let's go back to 90 volts. All right, there we are at 90. We're getting a little over 100 milliamps here. Okay, and notice we're just getting phantom voltage here. So now the voltage can drain off, but it's not allowed. You're getting capacitance in the wires, can't drain off. You got a 10 meg internal impedance in here, so it looks like there's voltage there, but in reality it's just developing a small charge. There's nothing to drain it. All right, so let's take a quick look. I'm just going to go, I'll just verify 3 to 4. Let's see, we're getting, should be around 90. 3 and 4. There we go. Now we'll go 1 to 2 is the filament voltage for the main lines. So 1 to 2, meaning the RF tubes and so forth. Get that in here. There, there. Yep, about 2 volts. I'll go to about 2.5 for the filaments. That's good. And now we'll go, we're going to check 1 to 6, which is to the pigtail, which is here. About 1, okay. I can try 2 to 6. About 1, okay. All right, now we're going to go down here to 7 to 8. 7 to 8 is the filaments for the 71As. All right, so 7 and 8 are 7 and 8. Okay, 4 volts. Looks good. And there's also a center tap. Let's go 7 to 5. So 7 to 5. It's about half that. That's good. 5 is also connected to pole 1 of the BC. Yep, looks good. All right. I'll assume 8's fine too. Okay, 10 and 11 are the filaments for the rectifier. So there's 11, and here's 10. Okay, it's about 1 volt. Looking good for that. And we already, see, we do this to say 12. So we know that 12 to 9 is high voltage, 560. Okay, let's go to pin 6, which should go to pole 1 on the capacitor here. Let's see what we get here. Yep, 270. Okay, it's time for me to put the tuning condenser back onto the radio. So I've got this thin piece right here. We're going to see what we can do about it. It doesn't really want to go back straight, and there's a bit of a split right here. But it is curling up and it interferes. When you turn this, you can see it wants to run into that right there. And this causes it to get broken as it has to pop into that area. So I think what I'm going to do is take this off and see what I can do with it. I didn't finish cleaning this anyway. And then when I have that open, I think I'm going to take this top frame off and put some lube in here on these support points. And then I'll put it back on, double check that I didn't mess anything up with my spacing. And then see what we can do with this. So hang on. Okay, that's loose from here. Yep. Make sure that didn't want to slam. Okay. Okay, that comes off. You can kind of see how this engages. It's a brass disc and a metal disc that's spring-loaded that squeezes on this plate, and as you turn this, it turns around on this track, and that's what moves this. It also drives the center shaft of the condenser, and it also provides some resistance. And you can see how the coating has been removed from where these rivets are. But we'll see if we can clean this up some. All right, and get this out. I think all you got to do is kind of see there's like a relief here. Just bring it over to where that relief is. If I can do that. And once it gets there, let's see here. Okay, now it's released, and now you just kind of pass it through like so. And then this comes out. Alright, I've already cleaned this piece up and put bow shield on it. And now I can address these two bits. And then I can put some lube on this front cradle and this back support here. And I think this turned out looking pretty nice. Okay, so this just comes out like so. Comes out like so. And now turn it to where it's not engaged. Lift out the front cradle and slip it out of the back, and there we go. Alright, I'm going to look at putting some lubricant in here. I think I'm just going to clean it just a little bit, and then I'm going to put some lithium grease in there. Yeah, it's going to be better to have that out of there. That's not helping. It might be graphite, but I think it's mainly just dirty grease, right? And dirty grease does not help the cause. Alright, I'm going to work on this for a bit, and then we'll move on to the next part. Okay, I'm just going to use some lithium grease here. Somebody, I'm sorry, I don't remember your name, beg your pardon. Somebody made a comment, I never thought about cutting a Q-tip. That makes a nice rolled up paper thing. You cut a point on it and use it for cleaning. It's pretty handy. I'm glad that helped. This could be known for something, right? Let's see if I can get some on this side here. I said I'll wipe that excess off in just a minute. Back in. You could do this from time to time if you wanted to. Alright. So, unmesh position. Bottom first, back first rather. Then slip it into the front cradle. Like so. Let it engage. Ooh, that feels slippy. That feels really slippy. Cool. Alright, so now we'll put this on reverse order. Bring this around the back. Clip it on. And now just stretch it in position here. There we go. That all still looks good. And now this side. This long tank comes in from the back. It's in the top hole. That comes across the top and hooks onto here. Okay, and gets in position. Okay. That'll do the trick there, I think. I put a drop or two in here too, won't hurt anything. Ooh, that feels good. Alright, so that's done. I'm looking at the gap in the plates, see if it moved any from what I adjusted. No, looks good. Okay, so that's ready to go back on. Now we'll turn our attention to this. So I have tried heating this up and trying to see if I can influence it to straighten out, and it just doesn't really look like it wants to do it. I could try it and force it, but I thought I'd try something different. So I reached out to our friends at Radio Days. They were kind enough to send me this for money. And let me see if it lines up okay. I'm sure that it will, to be honest. Yep, that looks good. Okay. So I think no matter what, I'm going to take this off anyway. Now, one of the things I notice is how much thicker this is. You know, it looks like it's like white, I guess, or maybe they printed white on one side, but it looks like it's got a white tint on it. I guess it's Lexan. And then it looks like they printed not only the scale, but also the color. I know it's available as white or amber, and I wanted it to match what was there, so I ordered amber. But what I'm going to do is I'm going to take this off, and then I'll clean this. And then we'll look at whether this can be done anything with it off of the wheel. And then if not, I'll put that on. But I'm thinking that because of the thickness difference of this, I may have to go away from having the rivets and just put a small screw in there. We'll see about that. Okay, it is off. So it goes on to the front side. Okay, I'll clean this up a little bit. I'm not going to go too crazy. I just want to make sure I don't have any burrs on here. I don't want to smooth it out too much though. It needs to have friction to drive. On the back here I might do something about the rust that's starting to show up here. It looks like it's fairly flat. It looks like it might be bent down a little bit here, but it's pretty close to being flat. Okay, I'll get this cleaned up, and then we'll look to see what I think I can do with this. Since I've got a replacement, I may not waste much time on it. So I've been working on getting things pulled together to try to flatten this out. I may try to do that later, but I've noticed that this thing has gotten so brittle that a part of it broke off, I guess when I was taking the rivet out. So this end here would not be sure. I'm going to just take advantage of the fact I have the replacement from Radio Days. I'm just going to use it. It looks really nice. And I'll just slip this into I guess an envelope or something and stick it in the cabinet maybe. But if I try to go back and try to flatten this, I'll let you know how it goes and how I did it. But I really don't see much point when you can get a replacement. It's so nice. But anyway, that's what I'm going to do with that. All right, so the other parts of this I've got pretty well cleaned up. I've got bow shield on it right now, letting it kind of dry like you're supposed to let it do. And then I'm going to try to put the other one on. Some of the holes don't line up. I may punch new ones, or we'll see how we do on that. But anyway, we'll get to that a little bit later. I need to let this dry. I did need to take the set screw, and I ran it through a die because it had a burr where, you know, the screwdrivers got on there and kind of damaged the thread on the side of the slot. And I got that straightened out and got it installed with some oil, and that should be fine. But I'll let this dry off, and then I'll get to, in just a moment, you'll see it. I'll go to put the new dial on, we'll see how it looks. Okay, so I've gone ahead and mounted the new dial from Radio Days. It looks beautiful. Had to do a few modifications to get it all to fit in here. The screw holes were not exactly lined up with this plate. Don't know why, but I was able to go to number 2 size screws, and they had enough clearance in there where they would go in, and I've snugged that down. They've got nuts in the back side. I went and got short ones so they don't interfere with anything. You see the mechanism's working good. And I think it looks very nice. I had to do a little bit of relieving here, which will not show. And on the piece in here, there's a roll pin that sticks out of one side. That sticks out so far that it was beginning to hit this because this is so much thicker than this was. So I just went in there with a Dremel and ground it down. It didn't matter. That's the side that would be poked out if it ever needed to be removed. So it wasn't a big deal. I've got the new knob on it. I've centered it about as best as I can right now. You know, maybe one day I'll get in there and try to tweak it, but I think I've got it right at the halfway point here. And I got the tuning condenser pretty much at halfway. It's close enough for right now. And we will go from there. But yeah, seems to work smoothly. It goes from stop to stop. Good. Okay, what I'm going to do is go ahead and get this put onto the chassis, get that all done, and then what I think I'm going to do is go ahead and just start putting the tubes in, and we'll start to see how it goes. I may start with the rectifier, like I said before, and then just build it up before, but I decided to go ahead and put this in. I'm also going to need to bring the cabinet over here with the field coil and plug that into the chassis, so I'm going to have to rearrange some stuff to make some room. But we'll get onto that in a minute. When we come back, we should have all that ready. Putting this on now. Okay, I've got the tuning capacitor back in. Seems to be working really well. And we've got a fresh bulb put in. It's kind of interesting. Once you hook up this circuit, once you hook up those lines to the capacitors in here, and you try to measure the capacitance of these, you don't get a measurement really anymore because it's in parallel with the coils that are here. So from there to ground. So it's you don't really get a resistance reading, other than it's just not a straight open circuit. I mean, it's got resistance, which is the resistance of the coils. Okay, looks nice. I'm going to, as you can see, I have all the tubes in. So what I'll do is I'll bring it up very slow. Now that we have the rectifier in, we'll be getting voltage through the system, but now that I have the tubes in, we'll go ahead and start maybe getting conduction, and we'll see what goes on. I got to bring the other part over so that I have the field coil to hook in as well. I need to do that. And then for it to do any reception, I'll have to put the tube shield back on. So here's the tube shield. It had rust on the top, so I went ahead and did de-rusting on this and got it all done. It looks nice. The parts that will show, which would be kind of like this part and up here. This part here I haven't done yet because I needed something to hold on to when I was cleaning it, so that I didn't get any water on the tag. That's the original tag. So I'm going to try to preserve it. So I'll go around it and not get any water or anything on it. And I'll leave a little bit of this around the side, which is just fine. But I'll do that later. I'm going to go ahead and hook this up, and then we'll have the shield in place. So it goes on like so. And there's two screws that will hold that in place here, but I don't need to put that on right now because I've got there's a friction clamp here that's holding on the inside. It's right here. And that's grounding this shield here. So that's good. Alright. So now let me get the field coil over. Okay, we're ready to go. We have the rectifier tube in as well as all the other tubes. And I've got the shield on as well for the RF tubes. So the assembly is complete over here. I'm tied on here for point D, which is close to the B plus. It's after the filter choke. But the rectifier is in as well as all the other tubes as well. We got the field coil is in and plugged in. And we've got, this will show the voltage coming in. So I'm going through, once again, going through a isolation transformer, a variac, a dim bulb is in the circuit. I've got a 1 amp fuse, then I come to here. This is showing us the voltage coming out of the panel that's going into the radio. This will be the current we're going to be watching. Once again, this is AC amps, and it's 1 amp full scale. This has been running around mid-scale when it's been operating. Okay, if you can see it here, this little guy I have right over here just monitoring the voltage coming into the transformer. It'll be monitoring it after the CL90 thermistor. So once again, this right here is monitoring our B+. This will be the voltage going into the transformer. This is the test voltage I'll be looking at when I'm operating the variac. I'm going to be watching this very closely. The on-off switch is on. The volume is, I'll put it a little bit, only about 25% or so. Okay, I think we're ready to go. Alright, so this is in DC now because we are in downstream of the rectifier, so we're in DC. And I think we are ready to go. I'll be using this to monitor voltage as I go around, and I'll be reading it here. We're going to start off by looking at the B+. So voltage is all the way down, power coming on, and here we go. There's 10 volts. Looking at it right here. And we can see this is what the voltage is going through the thermistor, getting to the transformer. So there we go, going up. 20 volts. 30 volts. Seeing a little bit of amperage moving. 40 volts, about 150 milliamps. There's 50 volts, still under 200 milliamps. Watching what's happening here. To watch my connections, I'm not sure they're good. We'll see. 60 volts. Could be that our rectifier isn't conducting yet. It should be though. Yeah, we're at 50 volts. All right, there we go. 70 volts right there. So that's 70 volts. We're at 106 coming out of the rectifier. Let's go on up some more. 80 volts. Once again, we're watching to see if we start to see the other tube start to conduct. We're at 140 volts on the B+, heading for the plates. You hear the frogs outside singing. There's 90 volts going in. We're at 167 volts out of the for the B+. 0.4 amps. Let's see if I see any glow yet. I don't see any glow. I'm getting glow on the bulb behind the dial. I'm getting glow on the dim bulb. Just going up. There's 100 volts going in. We're about half an amp. Let's see if we're picking up anything here. We are. That's a good sign, huh? Alright, I'm going to turn the tuning condenser a little bit. I do have an antenna hooked up. It's going up. It's 110 volts. About a little bit over a half an amp.
Để chúng ta ăn mặn chúng ta sẽ thấy khó chịu vì đó chính
turn the voltage up further.
Opportunities abound, not able to cash in. That's the story of this one for me tonight at Kauffman Stadium in Kansas City. All right, let's go ahead and go to those Xfinity listener lines at 713-212.
Okay, I'm maxing out on the bulb that I have in the dim bulb. I'm going to lower the voltage coming out of the variac, and then I'm going to bypass the bulb. I'm still going to have a 1 amp fuse in there, so I'm still going to be safe. So if I'm going to lower the voltage down before I bypass. Bypassing now. Okay, it's about 115 here. So you can see what the thermistor is doing for us, right? We've got 120 volts coming in, and after the thermistor, the transformer is seeing 115 volts, which is just what we want. Okay, now so we've got the thing working, I need to go in now and redo the alignment on all of these because they're all out of whack for sure now. So I'll do that next, but I got to get set up and with my signal generator and so forth. So I'll do that and I'll do that next. So hang on. Okay, we're all set up to do the alignment. I've got the signal generator up here on, tuned to 1400 kilocycles, 1.4 meg. And what we're going to do is, I've got the, let's see, got the modulation is on, signal up. I need to tune this to 1400. So you can find it. I found it. Okay, well the good news about that is that I was afraid I wouldn't be able to find it at all after I had this all apart, and I had counted the turns down on each of the trimmers and got them to where we backed them back out so you can get to where you can see them. Hang on, hang on. Can you see them? Right down there. So we counted the turns in on each of those trimmers, then counted them back out to hopefully get close, and we did. So that's pretty cool. Alright, so I've got the modulation turned up really loud though on the signal generator. So let me adjust my levels. Turn the volume up, turn the level down, turn the volume up, turn the volume down. So now you can just barely hear it up out of the noise floor. Okay, so what we need to do is adjust each of these trimmers. We do this one first and work our way this way, and I'll do it several times. So do this one. That in there. That in there. Guess I missed that one. Let's see. Leave that alone. Turn my signal. Boy, I got the signal all the way up. Okay, turn that. I mean, all the way down. Down there. Get this signal squeaker. Hold on. Hang on. I know I'm botching this. Hang on. Here we go. Down low. You can hear the peak. There's the peak. I think that's pretty good. Now let me turn the volume down and hook up the regular antenna. I can find it. Here it is. Get the coil out of the way. Alright. Let's run up and see if we can get any reception here after all that fun.
Ở trong cái chương trình học hè này là có những cái hoạt động giống như là những cái hoạt động
There's no automatic volume control, so it kind of has this issue. There's not a lot of stations available up here unless I get outside of the shop to the lower end of the scale, where most of my stations are.
Once the storm's passed, without the hassles of glasses or contacts, with Berkeley Eye Center's LASIK procedure.
Here's my station for listening to the baseball game.
526-EYEX.
790.
Makes his major league debut tonight as the Spurs take on the Royals at 6:40 on the Sports Talk 790. TRFs will join in progress at 7. Our next update.
Feeding or pruning, Ability Tree experts can take care of all of your tree needs. Call 28144.
All right. Something in there. All right. Let me get the camera reset. Let me get the camera reset. Okay, most of my stations are down low.
Number 4, Texans.com.
700 KSEV.
Number 4, Texans.com. The KSEV weather center.
740 KTRH.
Rock.com and step into a brighter, financially secure.
30 to 40% off coming.
And KBME at 790. That's the station I usually listen to the ball game on. And I've got a Vietnamese station way up here, and there's a few others that you can pick up sometimes, but not normally in the shop. So I think this thing is working really good. We got the cabinet all cleaned up. We got all the repairs done. We made the mistake of painting the transformer, and everything looked original, so we had to fix everything else up. And I think it turned out looking pretty good. At the end of this, I'll show a comparison of before and after for you to look at if you want to. So this is all pretty much done. So we got the chassis taken care of. We got the new cord. We got the fuse. We got the thermistor in there. We've got a polarized line cord on it now. So this is now really good to go and could be plugged into the house. So that's a big step forward on this. That really just leaves the cabinet issue. Now the cabinet has some glue up problems. This front panel wants to come off. There's part of it over here on the side that is loose. Sorry, get this one over. This part here is loose. There's a piece of veneer missing right here where this kind of split out. And we'll see what we end up doing on that. But for right now, that's it for this 94-year-old TRF radio. It's a Philco Model 20. And I think it turned out looking really nice. So we really appreciate you guys watching and following along this fairly long episode. I appreciate it. Thanks a lot for all the kind comments, and I'll see you next time. Thanks. Bye.
Diving into the edition of the Astros on Deck show, we're able to lead them into another good Christian Javier start last night. Not ideal in that he left in a tie game after having a 3-run lead, but you get 6 innings and allow 3 runs, essentially, from Christian Javier. That's just fine. Rafael Montero did his job. The rest of the bullpen did their job. And it's unfair to say Wander Suero didn't do his job. He threw 2 pitches. He gave up a hit. And granted, it goes in the books as a single.